In this episode of the AHT Expert Talk, we're talking about the ambient temperature. And for that, I have brought Knut from our training department. Now, Knut, when we talk about ambient temperature, how has it evolved in the last couple of years?
First of all, Michael, thanks for being here. When we are talking ambient temperature in the media, we will get influenced about climate change, right? So we see that we have more rain, that the temperatures are rising, that the ice glaciers are going down, that we can not get in the Alps to get skiing or something else. So how did it come? There we see absolutely a rising of the ambient temperature up to 1900. Mm-hmm. So what will change there? We see, okay, there is a pre-industrial period and a period afterwards. Where did it come from, the rising of the temperature? Coming from the CO2 in the air, and the pollution of the CO2. Mm-hmm. That's the point.
Okay. Now, when we look into commercial refrigeration, what is actually the impact that this rising temperature has quite generally on commercial refrigeration systems?
Absolutely. If you look on the normal cooling circuit, you have a compressor, you have a condensator, you have an expansion valve, evaporator, and then going back to the compressor. So where is the influence of the ambient temperature? Absolutely in the condenser. Mm-hmm. If the ambient temperature is rising up, you have difficulties to get the refrigerant cooled down in the condenser. Mm-hmm. Normally, in a normal circuit, we defined an ambient temperature of 30 degrees. Mm-hmm. But if you are looking in the near past, when will we have summer? The ambient temperature, you never see 30 degrees, 31. Mm-hmm. You get more 32, 35, 38. Mm-hmm. And if you remember where the condensers are standing, they're always standing on the roof. Mm-hmm. And on the roof, you have then 38, 40 degrees.
Okay.
So you will see that the condensers is working on a very hard position. Mm-hmm. And the more the temperature in the condenser is rising, you define 1 Kelvin more in the condenser temperature, 2 up to 4% is more the energy consumption.
Okay.
Because of the compressor has more work. Mm-hmm. It's coming from the evaporator temperature is still on the same point, but the condenser temperature is rising.
Okay.
So the compressor has to work more.
Okay.
So easy.
All right. So that means the energy efficiency actually drops the warmer it is outside.
Absolutely. That's the point.
Yeah. Okay. Now, when we look at the remote CO2 system, for example, I know we have these high pressures and everything. How is it actually affected when we talk about the ambient temperature there?
It's easy because CO2 is not working like a normal refrigerant. In CO2, there we have 2 points. One point is the critical point, okay, and that's what we are talking about when we are talking about ambient temperatures. The critical point is about above 31 degree and 74 bar. That's the point where the CO2 is changing. Something is changing. Above, we are talking about subcritical. And above this temperature, we are talking about transcritical. So what is meaning of transcritical? Subcritical, the CO2 in the condenser is normal condensing. Temperature is energy is going to the air, and that's it. The transcritical point, there we do not condense anything. The CO2 is not condensing. We are only changing the energy.
Okay.
And that's the point when we are talking about climate change. CO2 is created. It's a kind of it's not created because CO2 is a normal air pollution. It's not a physical made or industrial made referent. It's natural, and that's the point when we are talking cooling system with CO2. When we see in Southern Europe, the ambient temperature over the year in the range is about 25, 28 degrees, but in the warmer summer conditions, you have peaks about 35 up to 40, 42, 45. And that's normal over a long range of time. In May, June, July, August, there are 3, 4, 5 months with this temperature. And with normal referent like R404A or something else, the condensers cannot work. They cannot handle this ambient temperature. So that's a reason for using CO2 in such southern climate range, climate areas.
So that means as soon as we have this high ambient temperature, we need to be subcritical.
Yeah.
And if we talk about the efficiency there again, if I have a system that is running transcritical, does it mean it's less energy efficient than one that does not run transcritical?
Absolutely. You cannot say. The point is, when we want to sell frozen good in Southern Europe, we have to build any cooling system. A normal cooling system with normal referent, you cannot make it work with ambient temperature above 38, 40, 42 degrees. It will not work because of the standards of this referent. If you see R404, the maximum point of R404 is about 38 degrees in the circuit.
Okay.
When you have 40 degrees, it will not work. So you have to put water on the condenser or something else. So if you want to build a cooling system for such a reason, not a reason, a region, then you do not have another chance to use CO2 because CO2 is still working with ambient temperature of 40, 45, 42, 40, up to 45 degrees. Absolutely right if you are looking at the energy consumption. The higher the ambient temperature, the lower is the COP of the compressor, because the compressor is working between maybe of normal cooling -5 or 0 degrees on the suction side, and 32 up to, let's talk about bars, up to 74. It's a transcritical point. So your system is working between 90 and 115 bar on the condenser side. On the that's, you do not have another chance to get CO2 in these regions.
Okay. So one alternative solution to remote CO2 could be the SPI water loop technology.
Absolutely right, yeah.
By that, how is it there with the energy efficiency? Is it like the same? I assume that the higher the ambient temperature, no matter what kind of system you have, it's always a bit less on the energy efficiency side.
That's absolutely clear. Each ambient temperature, if it's 15 degrees, 20 degrees, or 40 degrees, have an influence of the circuit, absolutely clear.
Okay.
But when we are talking about a water loop system, then we are talking about where to put the condensing energy. If we are looking on our SPI or FPI systems, then you have the condenser right in the middle of the supermarket. You connect water lines to this condenser, to the water cold condenser, and put the energy outside. And there you can cool this water down with CO2 or whatever you want.
Okay. Now, if we look at Europe just as an example, does it also mean that in Northern Europe, we are using less energy for the refrigeration system compared to the south of Europe?
Absolutely. If you see the range of the mid-range of the temperatures over the year, then in Northern Europe you have something, I think 5 up to maximum 15 range. In Southern Europe you have 25 up to 30.
Okay.
So when you will work your CO2 system or any cooling system with a low ambient temperature lower than 20 degrees, then you have efficiency perfect.
Okay.
It's running well. The COP, the compressor is running perfect. The condensing temperature is above of any critical point. And that's the point why the cooling system in the northern part of Europe is working well.
Okay.
Remember, each Kelvin of ambient temperature we are rising or we are less rising, 2 up to 4% less energy you have to put in the system. If you're running a system with 20 degrees ambient temperature or 40 degrees ambient temperature, remember 20 up to 40, it's 20K, 20 minimum for the 2%, you have 40% better working system.
Which is quite an impressive number.
Absolutely. And that's normal. You do not have to do anything about the system. You are not putting an ejector in or a subcooler or something else. It's just because of the ambient temperature.
Okay. Now, if we look in the future, we, I believe, can expect that the ambient temperature will rise further.
Yeah.
So
climate change, we cannot change it.
Yeah.
I think cannot, it's the wrong word. We have to do something. The government have to do something. I think we have to go away from the normal cars. We have to go to the electrical cars. We have to change some industrial production, green H2 and something else. We have to do some. We have to buy not only things in plastic. We both can change anything.
Yeah. But anyhow, in the expectation of the rising ambient temperature, that also means there's even more pressure on a commercial refrigeration system to be energy efficient.
Yeah.
So is there anything in the pipeline, any innovation, something that can help us in the near future?
I think we in the real system, pipes, compressors, condensers, evaporators, expansion valves, I do not think that in this hardware we can do anything else. So it's now up to us to create system or to design system that not working for ambient temperature like we defined in the past, maximum 30, 31, 32 degrees. No, we have to design the systems up to 38, 40 degrees.
Okay.
So future, have a look in the future. And absolutely klar, the future, the ambient temperature will rise. Not like 5-10 degrees, but from the 1900s up to now, we see that the ambient temperature is rising 1 degree, 1.5, something like this, only a small range, but it belongs to us to get this in a range that we can handle this, right?
All right. Thank you, Knut. Thank you for sharing your knowledge. Very interesting. So ambient temperature is a very important topic that should definitely be considered when you're choosing a commercial refrigeration system. Thank you for taking the time to listen to us, and we'll catch you in the next Expert Talk. Thank you.
Thanks a lot.